if you've ever had an X-ray, you already know a bit about how this works. A doctor shines a beam of X-rays, which is a type of electromagnetic radiation, towards you. The X-rays pass through you and leave an image on a photographic plate. Now, that image is formed because X-rays don't pass through all of your body in the same way. They can pass easily through muscle and soft tissue, but they're absorbed to a much greater degree by bone, and hence the bone shows up as white on the image. Now, a similar technique can be used in other fields. For example, engineers can use the absorption of radiation to investigate materials. And in fact, they can use it to measure the thickness of materials because, as you might imagine, the thicker a material, the more radiation it will absorb. Now, if you've studied physics at school, you might have heard talk of half thickness, which is the exact thickness of a material required to absorb exactly half of the radiation. And you might even have heard of something called the absorption coefficient. Now, all of these things, from a simple look at the absorption of radiation to a look at the half thickness and to actually measuring the absorption coefficient, are things that can be done in a simple experiment at home. Now, obviously, we don't have X-rays, but we can use another part of the electromagnetic spectrum to do this in the same way. We can use visible light. The only difference between visible light and X-rays is that X-rays have a shorter wavelength and therefore a higher energy, and therefore they can pass through things that light can't pass through. Now, what I'm going to use is visible light as my radiation. My absorber, I'm going to use this tracing paper or baking paper, which you can get in the supermarket. Sometimes it's called oven paper, or it might be called greaseproof paper. What I've done is I've cut a strip of this, and I'm going to cut this into small squares, and this is going to be my absorber. And in order to measure the radiation getting through, I've got an app on the mobile phone which will measure the intensity of light. So let's get started.
Okay, so I'm ready to take my results now, and I've come to a space where I've got a bit of natural light. Unfortunately, it's not a lot of natural light today. There's a lot of cloud out there, and that can be a problem because small changes in the thickness of cloud can create a big difference in the light intensity that your phone detects, even if your eyes aren't really aware of much change. We'll try it anyway and see how it works. Now, the app I'm going to use for this is Physics Toolbox. I have the Pro version here, but the free version works just as well. It opens here at GeForce, but if you click on the menu, you can choose light meter. There it is. Now, initially you will see a graph, but at the bottom you'll notice there's an option for a digital readout, and that will give you a number. So my phone is reading at the moment around about 13 or 1300 or 1400 lux of light. Now, you'll notice lots of things will change that. If I turn it to face the window a bit better so it gets more light, that number goes right up. And if I cover the light sensor, that number goes right down. Now, because it's changing so quickly, it can be quite difficult to read. So you're going to have to decide whether you want to do it just by reading as quickly as you can to two significant figures, say, as best you can, or whether you want to do it really carefully and take several readings and take an average. So for example, for this level of light here, I could stop the phone, note that number. Stop it, note that number. Then that one. And then until I've got 3, 4, 5 readings, and then take an average of those. However, if you're going to do that, your experiment is of course going to take longer to do, which gives longer for the sky conditions to change, which might spoil your results anyway. So sometimes the best thing to do is to just go through and get the results as quickly as you can, as best as you can. And that's what I'm going to do today. Now, I've changed my mind a few times over what's the best way to do this. Initially, I was going to put these small pieces of paper, absorber, over the light sensor and see how that worked. But I found they were very fiddly, they didn't stay in place, and because they were directly on the phone, when I tried to move them, I was touching the phone and kept starting and stopping the app without meaning to. So after various attempts, I decided to take a little piece of card from the end of the inside of a kitchen roll, and I've made it into a little square shaped thing, which I'm going to sit on the phone over the light sensor. Now, I can now place some bigger sheets of absorber paper on that, they will stay in place, and I know that they're always the same distance from the light sensor. Okay, so that's how I'm going to do it for now. I'm going to go through and take these readings as quickly as possible. So I'm going to start with this as my base reading with no absorber on it. So it's around about 1630 or 40. Just as I say that, it starts to drop. So 1620. And then with one absorber on, it should drop. And with another one, it should drop again. With a third one, it should drop again. And a fourth one. And a fifth one, and a sixth one, and a seventh. And now we might be getting to the point where we won't see much more change, but I'm going to go for the last one. Okay, now I'm going to go and record those results properly and test and see what kind of pattern that gives me. You can do the same, and then I'll show you what to do with those results.